In this section, we will talk about how AMD's next-gen Ryzen 7000 series CPUs are based on the Zen 4 architecture and the 5nm manufacturing process, which offer significant performance and efficiency improvements over the previous generation. The Ryzen 7000 series CPUs are the first high-performance x86 desktop processors to use the 5nm process node, which enables higher transistor density, lower power consumption, and faster switching speeds. The 5nm process node is also optimized for AMD's Zen 4 architecture, which delivers a double-digit IPC uplift over Zen 3. IPC stands for instructions per cycle, and it measures how efficiently a processor can execute instructions. A higher IPC means more performance per clock cycle, which translates to faster and smoother gaming and content creation. The Zen 4 architecture also introduces several new features and enhancements to the Ryzen 7000 series CPUs, such as up to 16 cores and 32 threads for multitasking and parallel processing, boost clocks of up to 5.7 GHz, for single-core performance up to 144 MB of on-chip memory, including AMD's exclusive 3D V-cache technology, which stacks additional cache layers on top of the CPU cores to reduce latency and increase bandwidth, an all-new 6nm I/O die, which enables hardware-accelerated video encode/decode, light-duty graphics work, and multi-display support for PCIe 5.0 storage and Wi-Fi 6E connectivity for faster data transfer and lower latency. AMD Expo technology, which allows for easy overclocking and memory tuning for higher gaming performance compared to the previous generation. The Ryzen 7000 series CPUs offer impressive performance gains across various workloads. For example, the flagship Ryzen 9 7950X processor, which has 16 cores and 32 threads, offers up to 29% more single-core performance, 45% more compute performance for content creators in POV array, 15% faster gaming performance in select titles, 27% better performance per watt. The Ryzen 7000 series CPUs also outperform the competition in both gaming and content creation. For instance, the Ryzen 9 7950X processor offers up to 57% better content creation performance in V-Ray render compared to Intel's Core i9-12900K, 5% faster gaming performance across select titles than Intel's Core i9-11900K. The Ryzen 7000 series CPUs are compatible with AMD's new Socket AM5 platform, which is designed for longevity and upgradability. The Socket AM5 platform supports future AMD processors with new technologies that have not been announced yet, so you can enjoy the best performance for years to come. To sum up, AMD's next-gen Ryzen 7000 series CPUs are based on the Zen 4 architecture and the 5nm process node, which offer significant performance and efficiency improvements over the previous generation. The Ryzen 7000 series CPUs are ideal for gamers, enthusiasts, and content creators who want to experience the ultimate PC performance. One of the most exciting features of AMD's next-gen CPUs is their support for PCI Express 5.0 and DDR5 RAM, which will enable faster data transfer and memory bandwidth for gaming and content creation. In this section, we will explain how these technologies work and why they matter for AMD's brilliant plan. PCI Express 5.0 is the latest version of the interface that connects various components in a PC, such as the CPU, GPU, SSD, and network card. It doubles the bandwidth of PCI Express 4.0, which AMD already supports in its current Ryzen 5000 series CPUs. This means that PCI Express 5.0 can deliver up to 32 GB per second of data per lane, compared to 16 GB per second for PCI Express 4.0. With more lanes available in AMD's AM5 platform, which will support up to 24 PCIe 5.0 lanes, this translates to a massive increase in the total bandwidth available for high-performance devices. For example, a PCIe 5.0 x16 slot can provide up to 512 GB per second of bandwidth for a graphics card, which is twice as much as a PCIe 4.0 x16 slot. This will allow future GPUs to take advantage of higher resolutions, frame rates, and ray tracing effects without being bottlenecked by the interface. Similarly, a PCIe 5.0 x4 slot can provide up to 128 GB per second of bandwidth for an SSD, which is 4 times as much as a PCIe 4.0 x4 slot. This will enable faster loading times, smoother gameplay, and larger storage capacities for games and applications. DDR5 RAM is the next generation of memory technology that will replace DDR4 RAM and AMD's AM5 platform. It offers several advantages over DDR4 RAM, such as higher frequencies, lower voltages, larger capacities, and improved reliability. DDR5 RAM can operate at speeds up to 8,400 MHz, compared to 3,200 MHz for DDR4 RAM. This means that DDR5 RAM can deliver up to 67.2 GB per second of data per channel, compared to 25.6 GB per second for DDR4 RAM. With dual-channel support in AMD's AM5 platform, this translates to a total memory bandwidth of up to 134.4 GB per second, which is more than twice as much as DDR4 RAM. Higher memory bandwidth is crucial for AMD's next-gen CPUs because it allows them to feed more data to their cores and cache faster and more efficiently. This will improve performance in tasks that are memory-intensive, such as gaming, video editing, rendering, and machine learning. Moreover, DDR5 RAM will also consume less power than DDR4 RAM, which will reduce heat generation and improve energy efficiency. DDR5 RAM will also support larger capacities per module than DDR4 RAM, which will enable users to install more memory in their systems without compromising speed or performance. By supporting PCI Express 5.0 and DDR5 RAM in its next-gen CPUs, AMD is showing its commitment to innovation and leadership in the PC market. These technologies will give AMD a significant edge over its competitors and enable it to deliver unparalleled performance and value for gamers and content creators alike. One of the most significant changes that AMD's next-gen CPUs will bring is the requirement of a new AM5 motherboard platform and a new socket, marking the end of the AM4 socket compatibility and paving the way for future innovations. But what does this mean for PC builders and enthusiasts? Let's find out. The AM5 socket is a major departure from AMD's previous PGA design, where the pins for connecting a chip to the motherboard are located on the chip itself. The AM5 socket adopts an LGA design, where the pins are located on the motherboard instead. This has several advantages, such as reducing the risk of damaging the CPU pins during installation or removal, improving power delivery and thermal performance, and allowing for more pins to accommodate new features.